Hello everyone. In my last lecture I discussed about the timing diagram. I told you there are various machine cycles for 8085 microprocessor like opcode fetch machine cycle, memory read machine cycle, memory write machine cycle, input output read machine cycle, input output write machine cycle. Then we have interrupt acknowledge machine cycle and bus idle machine cycle. So I discussed about the timing diagram of first 5 machine cycles, that is opcode fetch machine cycle, memory read machine cycle, memory write machine cycle, input output read machine cycle and input output write machine cycle. So all the 5 machine cycles, their timing diagram I have discussed in my previous lecture. 2 more machine cycles whose timing diagram is remaining, that is interrupt acknowledge machine cycle and bus idle machine cycle, that I will discuss in my later lectures when I will be discussing about the interrupt instructions, where you will need interrupt acknowledge machine cycle and that instruction which uses bus idle machine cycle. So I will discuss these 2 machine cycles, their timing diagrams later. So starting here in this lecture, I'll be starting the instruction set of 8085 microprocessor. So you have come across various programs in your microprocessor and microcontroller lab. You might have come across various instructions. So we'll study all those instructions here. So as I have told you earlier also that 8085 instruction set can also be classified depending on their operation. They can be classified as data transfer group, arithmetic group, logical group, stack control group, etc. depending on their operation. So here I have classified these instructions depending on their operation. So starting with first data transfer group, we'll study all the instructions that come under data transfer group, and in this way sequentially we'll proceed through all the groups. We'll cover all the groups of this all the groups like arithmetic group, logical group, etc. all the groups of the 8085 microprocessor. So data transfer group, as I've already told you that what is data transfer group instructions? Those instructions that transfer data from source to destination, they come under data transfer group instructions. So the first instruction, let's take the first instruction, that is MVI RD data. MVI is move instruction, RD is representing destination register. Data, here data will be an 8-bit data. M is the memory location which is specified by the content of HL register pair, and again here data is the 8-bit data. So for example, this instruction can be written in this form: MVI B57H. B, that is the destination register, 57 is the 8-bit data. Similarly, this instruction can also be written as MVI M 57H. M is the memory location which is specified by the content of HL register pair, and 57H is the 8-bit data. Here H represents the number which is written in hexadecimal format. Now, what does this instruction do? MVI RD data or MVI M data, what it does, it copies the data or moves the data immediately into the destination register. So what does this instruction do? It copies the 8-bit data immediately into the register that is mentioned. For example, MVI B57H, after the execution of this instruction, the register B of 8085 microprocessor will be loaded with 57H. So this is the instruction that I was talking about, MVI R 8-bit data. R is the register. You can mention any register like B, A, B, C, D, E, whatever data you can mention, whatever the whatever register you can mention, that is all the registers of 8085 microprocessor you can mention here, and any 8-bit data. So it loads the specified register with an 8-bit data given in the instruction. R may be A, B, C, D, E, H and L, and here 8-bit data will get stored in the register. Now, since this is a data transfer operation, in data transfer group instructions, all the instruction will only be transferring data from source to destination. There is no arithmetic or logical instruction or arithmetic or logical operation involved. So the flags of 8085 microprocessor won't get affected. Again, I am repeating, since data transfer group instructions only moves the content from one place to another or copies the content from one place to another, there is no arithmetic or logical operations involved. So the flags of 8085 microprocessor like sign flag, parity flag, etc., whatever the flags of 8085 microprocessor are, they won't get affected. So for all the instructions under data transfer group, we'll write flags affected no. Now, number of bytes, as I've already told you that in order to calculate the number of bytes in an instruction, you need to see whether there is a hexadecimal number mentioned in the instruction or not, because every instruction will be of 1 byte. Every instruction of 8085 microprocessor will be of 1 byte, because that 1 byte tells the opcode of that instruction. Now, if any hexadecimal number is mentioned in the instruction, that will tell that how many bytes of the instruction, how many bytes is that instruction is. So for example, MVIB 57H, 1 byte for the opcode of this instruction, and the second byte is because a hexadecimal, 1 byte hexadecimal number is mentioned in the instruction. So overall, this whole instruction is of 2 bytes. So here I have written MVIR data 8 bits. So the number of bytes are 1 byte for the opcode and 1 byte for the 8-bit data. So total number of bytes this instruction is 2 bytes. Now number of machine cycles involved in the execution of this instruction. Now, as I've told you, when you will be storing this instruction, you will write a program. If the program contains this instruction, then how this instruction will get stored in the memory? Obviously, every program you write will get stored in the memory that is attached, that is connected to the 8085 microprocessor. And I have told you that every memory has memory location. This memory location is of 1 byte, and the address which is representing this memory location will be of 16 bits. 16 bits, and the memory location is of 1 byte. Now if this instruction, if the instruction has to be stored in the memory, how this instruction will get stored? First the opcode will get stored, and the next and the consecutive memory or the successive memory location will get stored by the data which is mentioned in the instruction, the 8-bit data which is mentioned in the instruction. Since the instruction is of 2 bytes, therefore it will occupy 2 bytes of the memory, 2 bytes of the memory. So this instruction is stored in this way, first for opcode, and the second, whatever data is mentioned in the instruction, that data will get stored in the next memory location. Now for execution of this instruction, what will happen? First, microprocessor will fetch the opcode. First, it will fetch the opcode of the instruction. It will decode the opcode of the instruction. Once the instruction gets decoded in the microprocessor, microprocessor will come to know there is some data which is in the memory, and that data needs to get stored in the register B of microprocessor. So the second machine cycle will be used for fetching this data. So therefore there will be two machine cycles used for the execution of this instruction. First machine cycle for fetching the opcode, and the second machine cycle for fetching the data that is mentioned in the instruction. Once the data gets fetched, then what will happen? Execution of the instruction will take place. Means that data will get stored in the register B or any register of the microprocessor, whatever register is mentioned in the instruction. Now, how many T states are there? As I've told you, opcode fetch, I've told you that this instruction will need two machine cycles. One is opcode fetch machine cycle and the second one is memory read machine cycle. So opcode fetch machine cycle requires 4 T states generally, and memory read machine cycle requires 3 T states. So overall 4 plus 3 is equal to 7 T states. So this instruction will need 7 T states. Now what is the addressing mode of the instruction? As I have told you, any instruction of 8085 microprocessor, if it has I term, then it will be immediate addressing mode. Or I have told you, whatever the operand, that is operand is what? Operand is that data on which the microprocessor is going to work or operate on. So if that data is clearly mentioned in the instruction, then that type of instruction will have immediate addressing mode. So I hope this instruction is clear. We'll proceed further with the next instruction in my next lecture.